All right, hi everyone, welcome. We're going to cover chapter 1 here, which is really just about talking about psychologists, and that psychology itself is really sort of just a way of thinking, or a way that we kind of approach questions in the world. All right, let's go ahead and jump into it. All right, so chapter 1, psychology is a way of thinking. Here we're really going to break the chapter down into two main sections. So the first section, we're going to talk about research producers and research consumers, and kind of talk about both of these roles and how they work together, and how even any person can kind of act in both roles, and why each are important in their own context. And then we'll talk about how scientists work, so how they perform their research, how they actually go about the steps in the day-to-day of how to actually produce different types of research and knowledge. All right, so let's start off with the first section here, talking about research producers and research consumers specifically, and we'll break each of these down as we go. So in this section, we're going to talk about, again, why both the producer and consumer role are important, and also some specific benefits of being a good consumer of research. And so we'll break each of these down kind of as we progress. But first off, let's talk about the producer role. So these are people that actually conduct research, they produce research, and they do this in different contexts. And for you, I think thinking about how research and producing research for you is important in a lot of different contexts. And so if you kind of look at this and you think about kind of where you are in your research production journey, well, you're right at the beginning of it. And so starting off, I think it's important for you to understand this production of research just for this class, right? And for understanding how to properly produce research just for your classes. But also, if grad school is something you're considering doing, being prepared for grad school and understanding how to produce good research and continue evolving and making better research throughout grad school is also going to be a really sort of important process in this as well. And then maybe before grad school or just at this point in the game, you are interested in joining or working in a research lab, and that's something that you can do even as an undergrad student. Some of you may have done this, but that's something that you can do and produce research and be on this production side of things even now, especially after you finish this class. Oftentimes there are research labs here on campus that will allow you to volunteer and work and get some experience on the production side of research here, even at this level, which is really cool. All right, and so what about the consumer role, right? So producing research is great, but what about consuming research? And what are some things that you might need to think about in terms of how you consume different research? Well, again, like I said, obviously, you're going to want to understand this role in terms of this course and other psychology courses. One big thing just in the field of psychology is understanding what other people have done. I mean, any field of science builds on previous knowledge and previous research that's been done, and psychology is no exception. And so understanding really kind of how you fit into this and how you can consume past research in a productive, positive way is going to be helpful in you creating your own research and understanding sort of that process from an accurate perspective. But also not even just within psychology courses, but I think also just understanding research in your day-to-day life. So there are plenty of times, I think, where you might hear on the news or you might read an article that is talking about some new research that came out that shows X, Y, or Z. And I think a lot of people might just read those news articles at face value. And we're going to talk about this a little bit later in this lecture. But it's a challenge, I think, that people need to understand how to consume this research in an informed way so that they can really make their own understandings of what's being shared and what's being disseminated. And so understanding sort of other people's research is important even outside of coursework, even outside of research labs and in your day-to-day lives. And then, of course, the last one here, just being sort of your future career, right? Whatever it is you might want to do with a degree in psychology, whether that is more clinical focused or, going into more research-based practices, you're going to want to understand how to consume research no matter what you want to do sort of with with this type of degree. And so if we look at this, right, even if you think about people who aren't producing research, but people who are practicing, clinicians, even counselors, are people that are going to want to know what the knowledge in the field is and what past research has said works and what doesn't work. And being able to understand what that research has shown is really important in having effective and productive practices that you yourself participate in. And so this idea of evidence-based treatment, right? So using evidence from research that you are consuming to then base your treatment on that knowledge, and being accurate in your understanding of that knowledge is obviously important to produce good work from that research you're consuming. And again, specifically talking about, we've talked a little bit about some of these benefits, but if you think about this from, something you could ask yourself, right? But what do you gain by being a critical consumer of information? Well, I think you gain a lot, right? I think that you gain the ability to understand what true findings are. You gain the ability to take past research and past findings and adapt it to your own work or build off of past findings. If you're inaccurately understanding what previous research has shown, you're not going to be developing good research on your own because you're not starting from the right place. And so not even just, again, producing your own research, but even just, understanding research outside in the real world. There are lots of benefits, I think, to being able to understand and consume information critically, being able to come to conclusions yourself rather than relying on someone else's interpretation that you then just either believe or don't believe. All right, we're now going to switch into the second major section of this chapter, which is talking all about kind of how scientists work. So this is kind of cool, and we'll talk about some different aspects here of how scientists actually go through this process, and generally speaking, just how they work. So we can break this down into a few different areas, right? So first off, scientists are empiricists, right? So they generally look at empirical evidence, empirical data. They want to study things from an empirical standpoint to be able to test and measure and observe what it is that they are curious about. They test theories. So this is a big one, and we'll talk about this in terms of the scientific method, in terms of just generally how we kind of go about this process. But we refer to it as the theory data cycle, or generally speaking, we have a theory, we test it, we go through that process, and we find some information about that, and then we cycle back and either revise our theory or maybe provide additional support for it. But again, that's this idea here of testing theories is something that we as scientists do. We work in a community, right? So science and information and knowledge is shared amongst a group of people. And so we act as one member within that community to produce our research and make our spot in that field. And we gain a lot of information from other people inside of the community as well. We try to tackle both applied and basic problems. We're going to break this down as well, but looking again at the distinction between these two types of problems. We're going to get into that. Making our work public, right? So this is a big thing. And there's some debate or some challenges, I think, in this area right now with how we disseminate our work. But ideally, scientists want their work to be public for the general population, for anybody to be able to interpret and read and learn whatever it is that they particularly found. And then again, we talk to the world, right? So scientists are trying to get that knowledge out there. That's our goal, is to inform the world, whether that's through journals, academic journals, or whether that's people in journalism that have helped to share that information. Generally speaking, again, this is what scientists aim for, is for that knowledge to be shared. They don't want it locked in a box and private and something that doesn't actually get shared with the world. They want everyone to be able to interpret it. All right, so let's kind of dive into each of these points a little bit more. So in terms of empiricism and scientists being empiricists, first off, what is empiricism, if you aren't aware? Basically, it is just using the empirical method or looking at ways of taking evidence and computing it in more of mathematical, formulaic ways that can be tested, shown to be accurate or inaccurate, rather than just guessing or having guesses that can't be tested. And so we look at this idea of falsifiability. Being able to falsify claims is important for empiricism because it needs to be tested in sort of these ways. And so we use things like quantitative methods, which are just ways that we turn, observations, whether that is how many times someone does some behavior, into numbers, and we count those numbers, and then we can do things with those numbers and create data sets and information to compare to other things. And then we also have qualitative methods, which are more about descriptions of how we feel about different things. And so I think kind of going into these two different types of methods, quantitative and qualitative, we see both of these used in a lot of different types of research. Specifically, if you look at surveys, right, survey research, you might see both quantitative methods where they ask participants to respond with any given number, or they fill out a scale on like a Likert scale from strongly agree to strongly disagree, and those convert to numerical values, and those are quantitative methods. But we might also have qualitative methods where people just fill in information, they type out information, and we still get information from them that way. And so both of these are used and have their pros and cons. Oftentimes quantitative methods are much easier to work with and kind of do math and compare to one another, but qualitative methods sometimes provide more nuanced or informative information. And so using both in tandem together is kind of an important process in designing good research. And then lastly here is this idea of reflexivity, or basically just that scientists try to reflect on what they've done and question their own work and their own sort of theories to say, are there ways that I can improve on this? Is there something that maybe I approached from my perspective, but really I should look at this from a different perspective? And so these are important pieces of scientists approaching their field from an empiricist point of view. All right, let's talk now about the theory data cycle. So this is, again, under this idea that scientists test theories, and we'll use sort of this example here of the cupboard theory versus contact comfort theory. So if anybody isn't familiar with Harlow's monkey, you can see an image of it over on the right. But this is the idea that they wanted to really test this theory or this idea that baby monkeys would prefer either a cold steel mother that provided food and nourishment versus a warm, soft, comforting mother, but that didn't provide any type of food or nourishment. And so they wanted to test which one the monkeys would prefer. And they kind of went through this experiment and tested this. So let's talk about this in terms of this theory data cycle. So when we look at the cycle here, we see at the top, we have our theory. So our theory might be, what drives everything right from the get-go. And from that, we develop some research question, what we kind of want to find out more specifically about our theory. And that leads us to our research design, or how we're testing this specific hypothesis or prediction that we might have about our question. Now, this is sort of a newer step that we see here that's being sort of more commonly identified is this pre-registration. And so this is being incorporated into this idea of the theory data cycle, where we take that hypothesis and we do what's called pre-registering it. So we basically share it, almost publish it, before we've actually run any of our analyses. And I think a big part of this is to combat things like changing your hypothesis at the end or making your results align with what your predictions were. And so I think this is just generally good practice. It's a good thing that has been sort of established in research, is to say right at the beginning, this is my hypothesis and I'm going to test it. And that way, whatever you find, you can't go back and change what your initial hypothesis was. And so from that, we get data, our results, and that kind of leads to different things. If the data supports, our theory, our hypothesis, well, that's great. It leads back. It provides that strength in supporting our theory. If it doesn't, we find something different, well, maybe we have to go back and revise our hypothesis or our design or something along those lines. But it's this cycle of repetitive sort of work where we don't ever really end. We always are just kind of supporting theories and building to enhance and improve upon a lot of our work and our knowledge. And so again, if we look at this in the context of either the Harlow monkey or even another example we're looking at here, we can see how each of these things kind of break down into these particular processes. So our theory might be that contact comfort forms the basis of attachment. So in the Harlow's monkey, we see that contact comfort, that that contact with the warm, soft monkey, and that is what makes that attachment form. And so the monkeys will, prefer that type of mother. And so that brings us to the research question. Well, is that the case? Will the monkeys prefer warmth over nutrition? And so then we design some hypothesis or some test or design. So if we give two mothers, one with warmth, one with food, will the monkeys spend more time on the cozy mother versus the food mother? Just like we saw in that image. And maybe, again, we pre-register a hypothesis. This is a newer thing. So again, Harlow didn't do this, but new data, new research, new researchers are tending to do this more and more. And then we get our data that shows that, the monkeys did prefer the warm mother and spent more time with that cozy mother. And so we get that support for that initial theory. And again, you can see another example on the right with looking at this where maybe that theory or that data doesn't support the initial theory. And so we have to revise the theory or revise our design or our test to maybe look at it in a different way. And so I kind of like to end with this theory data cycle. Part of this is we're never really proving theories. I think that's an important thing to kind of distinguish here, right? So when we talk about supporting our theories, our data supports our theories, that's wonderful, but it doesn't ever prove the theory itself. There's no proving that's done often in research. Really, it is just providing support for our theories. And part of that is because we make sort of the assumption that, just because we found support for it doesn't mean that that is always going to be the case, right? We found one piece of evidence that says this is the way things are happening, but it does not account for all possible situations or explanations. And so we never prove theories, we only find support. And the more support in different contexts, settings, environments, the more that theory stands sort of to hold up, if you will. And so we say also that good theories are falsifiable, right? So a falsifiable theory is one that can be tested, can be proven, or can be shown to be wrong. And so I love giving this example where I can have a theory that there is a purple elephant that lives in another galaxy. And that's great, but it's not falsifiable. There's no way to test it. There's no way to prove it wrong. And so that theory isn't one that we can approach from the scientific method from this sort of perspective that scientists use from this empirical method of testing, because it's not falsifiable and there's no way to prove it wrong. And so good theories are falsifiable, and that's a crucial component in how we develop these. All right, we talked also about how scientists work in a community. And so again, we're all working together and nobody is often the sole purpose or the sole person, responsible for producing this breadth of knowledge about a given topic. Instead, we have sort of these communities that work together to provide different pieces of knowledge that all help to come some overarching understanding of a given topic. And so I want to talk here about Merton's scientific norms. And these are four main sort of norms that I think are really important to keep in mind, and something that scientists really do kind of value and put emphasis in here. So the first one is universalism. And I really love this one. This is the idea basically that anybody can be a scientist. Anybody can conduct research. And what's cool about this idea is that here, when we're talking about research and we're talking about what people produce, is the research is evaluated on its own merit, not on the merit of the person doing the research. So if you, even as an undergraduate student, found some finding that was groundbreaking and you conducted your research in a scientifically valid way, well, then your research should hold up and be valued just as much as if someone with 3 PhDs and a Nobel Prize had conducted it. That is the idea of universalism, is that anybody can produce research, and the research itself is what holds up its merit, not the person who has done it. The next one here is this idea of communality, which again, we talked a little bit about, but that scientists should share their knowledge, right? It is provided to the community. It is something that should benefit the community and work together to accomplish a lot of these goals. And then also we have the third one of disinterestedness, which is the idea that basically scientists should not be providing or putting their own sort of bias into their work. Ideally, scientists strive to uncover the truth. They strive for honest universal knowledge, and they shouldn't be biased or putting their own bias, their beliefs into their work. And so this is one that I think is hard, right? As humans, we struggle often to do this, but it is a goal that we strive to do in research, to look for the ground truth without bias. And then the last one is this idea of organized skepticism. So again, just the idea that scientists are skeptics, right? We want to question everything. We want to be skeptical of things that we see or what we find, because that is what allows us to test and falsify. And if we can't falsify or we can't show evidence against, then we provide more evidence that might be a valid theory. And so, being skeptical is a good thing in science. Even if you develop your own theory and it looks like it works, you should still be skeptical of even your own work, because that's how we uncover the truth, is by being skeptical of what we've found so far. Let's also now talk a little bit about this distinction between applied and basic research. So really kind of distinguish these two things in a general sense, is that applied research really is research that focuses on real world application. So how problems or how things might work in the real world in a real setting. Whereas basic research is looking at more uncovering the more raw understanding of the workings of a person or the mind or something in that nature, more for the goal of knowledge itself. Whereas applied research takes that knowledge and provides some actual real world application, benefit, or solution within the real world. And so I think a fun example to talk about here on this one is if you look at, say, basic research that looks to uncover how our eyes work. How do our eyes take in the photons, the senses from the light around us, and what happens there? And there are researchers that study that. They investigate this, and they learn that we have receptors for different types of light, and we have different types of cones that are sensitive to red, blue, or green light. And then they send those signals into our brain, and we perceive the world around us. And that's really basic research in nature, just to understand the workings, but not really anything beyond that. Applied research, on the other hand, might come in and say, oh, this is great. We've uncovered that some people have deficiencies in some of these cones, and they can't distinguish between red and green, or they have some color blindness. So how can we design systems? How can we design screens or monitors or displays to help account for some of those limitations that they might have? And this would be more applied research that is having some more real world application to the same knowledge that was gained from the basic research. And then again, we've touched on this, but just the idea that scientists like to make their work public. So this is a challenge, I think, more and more, though we are seeing more things like open source journals that are providing information, disseminating research articles and work to anybody, right? So the idea is that making your work public, making it available, allows other people to build off of your work and also maybe test, maybe be skeptical of your work. And again, while that might sound a little scary, it's a good thing, right? And it is good in uncovering the truth to have people question your work, because if they can show that what you did was wrong, well, then you probably shouldn't be putting a lot of emphasis in that theory or that finding, if that's the case. So if our goal is to uncover the truth, then we want to question and we want other people to critically evaluate our work, which we can do by sharing it with the scientific community or the community in general. And again, how we disseminate this work, I think, is important to kind of understand, because I think there are some people that are involved in this process that can make the outcomes or the findings maybe less accurate than they were initially intended to be. And so we can see sort of this scientific news cycle. And the general goal of this, or the general idea of what this is saying, is that you might, produce some research. You did a study, you collected data, and you found that A is correlated with B, right? And that's great. But you also found that is given C, assuming D under E conditions. So it's a very unique subset of A and B being related to one another. But there's not a lot of maybe meaning behind that. But you did find some support that that is a thing. Well, now the university helps disseminate that work and explains that scientists found a link between A and B. And then maybe some news organization misinterprets or adds their own sort of flair to this and reports that A causes B, says some scientist. And then, the internet takes this and they run with it. And we see the story sort of evolve and change and grow that, oh, now A is out to get us, or A causes B all of the time, and what you don't know about A can kill you. And so I'm wearing this hat to ward off A. I love how that sort of ends with your grandma not understanding your own research. But this is really kind of a big challenge I think we have in society. Not necessarily to anybody's fault, but just that we all have sort of a role that we play in trying to understand information and knowledge. And being sort of, again, a critical consumer of information, I think, is not only understanding that first step, not only understanding the true meaning behind what this is, but also, identifying that there are these other aspects, these other ways that information is represented, and being skeptical of what that means when you read it. So when you read a news article that says A causes B all of the time, well, understand that that has gone through this cycle and maybe should have some critical evaluation placed on those claims. All right, and so that wraps up chapter 1, a little bit of a shorter one here, but really the idea here is just to kind of get you started, get you thinking about this idea of psychology being this way of thinking and how we kind of approach some of these problems in our field.